Hello everyone. Today we are going to discuss about introduction to Matlab PLC Coder. It is specifically for generate IEC 611313 structured text and ladder diagrams for PLCs and PSCs. Here, what is IEC 611313 slash 3 standard protocol? Is a first vendor independent standardized programming language for industrial automations. It is established by International Electrotechnical Commission, that is IEC. It is a standard. It is also combined with a new powerful prescale chip architectures enable an entire controller to be delivered in an embedded device also. Also, control programs can run distributed and independently rather than larger controllers. No longer are thousands of lines of control programs required running in one controller for complex automation applications. Also, this increases the performance, it improves reliability and simplifying the programs. This IEC 611313 is the international standard for programming controller language. Here, the 5 programming languages that is suitable for that is defined in IEC 61131 standards. It's 5 standards is that is the first one is the ladder diagram, better known as ladder logic, and functional block diagram FBD, then sequential function chart, that is SFC, then instruction list IL, it's a structured text ST. It is here SFC is used for pictorial representation of systems operation. Then now we can move to this PPT. This Simulink Matlab having interactive toolbox called Simulink PLC Coder. It supports many third-party IDEs including Siemens STEP and Rockwell Automation Studio and CODESYS and PLCopen XML. Then this Simulink PLC Coder generate structured text from your control system model and comprising feedback loops, modern state logic and math-intensive algorithms. Then also you can apply optimization also by default to reduce the memory size and increase execution speed of the generated structured text and ladder diagrams. This optimization include dead code elimination, expression folding, and also subsystem reuse. What is subsystem reuse? So what is the main limitation of ladder logic performed by some other softwares, that is a traditional software, standard softwares? One of the limitation of pure ladder diagram is the inability to encapsulate code for reuse. Here, by using this Matlab Simulink PLC Coder, we can able to reuse or editing, debugging. You can also it is manageable. If you only programmed in a ladder diagram in standard softwares, programs would be unmanageably long, which makes coding, debugging, and editing very difficult. This can be avoided. This can be overcome by using this interactive Matlab Simulink PLC Coder toolbox. These are now we are going to discuss about temperature control simulation example and code generation. Here there are 3 types of code generation can be done by using the Simulink PLC Coder. First one is C coder, then HDL coder, then automatically you can generate ladder logic generation. This example shows how to model a temperature controller in Simulink by using ladder logic. There is a how to get the example. Just you type PLC underscore ladder underscore outset underscore complete command in your command Matlab command window. Otherwise, I have provided in description box the Matlab Simulink file. You can use it. Then this example also shows test case generation using Simulink design verifier, and C can generate C code generation and ladder code generation and ladder test bench generation. Then this is the once you type the command PLC demo underscore ladder outset complete command, you will get this type of Simulink model file. Here it has three parts are there. First one is HMI and temperature controller and house model. Here the HMI is nothing but what is HMI is in PLC. It is a most important one. It is a human machine interface. Most model control systems employ PLC programmable controller as a means to control motors, pumps, values, and various other equipments used in a process. Also, this computer-based HMI provides a means by which process personnel interact with the PLC control system. Then, what is the function of HMI? HMIs allows operators to start and stop cycles, adjust set points, and also perform other functions required to adjust and interact with a control process. Because of this human machine interface is a software based, they replace physical wires and controls with the software parameters, allowing them to adapted and adjusted very easily. Here some more description file is available here to open human machine interface block, and also you can after simulation you can get M file also. You can able to generate Matlab file from the Simulink file. You can convert into a Matlab script file. Because of this for use purpose you can get this data, get this Matlab file. Also you can view, if you click here means you can view ladder diagram. This is the set point and range as input. Also your temperature, outdoor temperature and indoor temperature also measured in this house block. Then what is a set point? A set point is a constant block, and normally it specifies the temperatures that might be maintained in indoor only. It is normally this default value is 70 degree Fahrenheit. Then range is the constant block. This specifies the range around the set point for the room temperature to fluctuate. It is a 50 degree Fahrenheit by default. Then temperature controller is a subsystem that has a AOI runner. AOI runner is nothing but add-on instruction. It's a subsystem. It's a runner controller. Inside this temperature controller, a ladder diagram function block is there. If you double click this block, you can get these options. In this option, select a logic routine option to view your ladder logic for the temperature controller. Here house is one of the subsystem which models the outside environment and house and the heater dynamics. And this is the ladder logic. Once you double click on temperature controller, you can get one window. Here also some options are available here. In this option, select logic routine option. You will get ladder logic like this. Okay, this ladder logic, what are the subsystems are available here? Your adder, subtractor, and GEQ and LEQ options are there. In rung file also there. The first rung calculates the set low value and set high value based on the set point and range inputs. Then this GEQ activates temperature H coil of the room temperature is greater than or equal to this set H value. Then similarly the LEQ block also activates this temperature L coil if the room temperature coil activates if the room temperature is less than or equal to this set L value. The final the lowest rung turns the heater on if the temperature L output is active, and turns the heater off if the temperature H output is active. Then after the settings, run the simulation. You click the run button to start simulation. Open this HMI block. Double click here. You will get in this type of window. Here there are three tabs are there. In this settings, the temperature controller settings used to allow changing the set point and range input values. Here ambient temperature allows changing the average outside the temperature and also range of its variations. This block is displays for heater status and inside and outside temperature graphs. It's a room temperature block. Then finally we can see by using logic analyzer also. You can generate Simulink design verifier by using logic analyzer block. How you can get in this Simulink window itself, the logic analyzer blocks is there. At the time of simulation, you can able to see logic analyzer output like this. This is a pre-processed Simulink model for SLTV test case generation by executing the following command also. This command once you type, you will get this type of logic analyzer output. Then open the controller subsystem and right click on the AOI runner block named temperature controller. Here also one more option before you run. Select a design verifier and generate test case for subsystem. Then also you can get C code generation. Before in model configuration parameter, you have to set some parameters for generation of C code or generation of HDL code or generation of PLCs code. These are all options are available here. Here before you generate a C code, ensure that in the target file in model configuration parameter you have to select ert.tlc file. Then this is a pre-processed Simulink model for C++ code generation by executing the following command in the Matlab command window. Here open the temperature controller block subsystem and right click on AY runner block named temperature controller. Later we will see how we can generate C code and C code generation and all. Then ladder code and test bench generation. By using in single click itself you can generate ladder code and you can generate test bench generation. How it is done? By using this tab, by using this command, you will get the test bench model also. Then select temperature controller runner block and right click PLC coder and generate code for subsystem to generate ladder code. This is the option must you have to select. Then only you will get the ladder code and also test bench generation can be done. To generate test bench, select the test bench for subsystem option in the PLC configuration parameters dialog and generate the code. Then what are the supported IDE platforms are there? Here the IDE is supported for so many languages we discuss. What are the languages? Here is ladder. First one is a ladder diagram. Second one is function block diagram. Then third one is a sequential function chart and industrial list, that is called as IEL. Then final one is a structured test. ST is called as ST. This Simulink PLC Coder already tested with the following IDE platforms. These IDE platforms also it supports the Matlab version, Simulink PLC Coder version. These are all the platforms, IDE platforms. It supports the PLC programming. Similarly, ladder diagram code generation. The Simulink PLC Coder product is tested with these following IDE platforms. These are for ladder logic generation. You must select these three targets. There's a 3S Smart Solutions CODESYS version, and then Rockwell Automation RS Logic 5000 series version 20, and also Rockwell Studio 5000 Logic Designer version. Then only you have to select these three IDE platforms. Then only you can able to generate ladder logic diagram and also the test bench code generation. After importing or creating the ladder diagrams model, we can do the following from the use of Matlab Simulink. You can edit the imported ladder diagram model from within Simulink by using the PLC adder library. Then also you can simulate the ladder diagram after importing the ladder diagram into Simulink. You can generate C code from the imported ladder diagram, and also you can integrate code into your existing C language based your simulation environment. We can also generate ladder diagram code from the imported ladder diagram, and also you can integrate code into Rockwell Automation IDE. Now we can see with real time. Now in this desktop, in this command window, you just type this command. This is a PLC demo ladder house it example. Once you enter, you will get in this type of Simulink window. Here there are already you mentioned that's HMI block shows three blocks. There is a HMI human machine interface blocks. It shows three different boxes, dialog boxes there. Temperature control settings and ambient temperature and room temperature. It's a normal value. Temperature control set point is normally 70. Here ambient temperature normally 50 is a default one. Then here the temperature controller inputs are set point and range. Then here this house model. In this house model, it shows the temperature, indoor temperature and outdoor temperatures, and these are all the input, average output temperature and the daily temperature variation. Once you want to, this is the description file. This hyperlink is provided to open HMI. Hyperlink is provided to open environmental configuration parameter of PLC demo ladder outset data M file. Here also you can view to ladder diagram. Once you click on temperature controller, the temperature controller runner option is there. In this runner option, once you double click on that, you will get this AOA block. In this AOA block, function block, there are variable table option and logic routine option and enable false routine and precons routine option is there. In variable table, you will select the inputs. There's a function block variable spreadsheet. Here itself, you can see the offset. You can adjust what are the inputs, what are the output port types and data types, what is the initial value, what is your false value, true value. You can all the things you can use this function table. You can apply. Then if you click logic routine, you can see the ladder logic diagram for your PLC programming. Then now already we mentioned, you discussed with this one what is the rung files it contains. Here what is a rung in a ladder logic diagram? Here this horizontal line in a ladder logic ladder diagram are called rungs. Okay, each one represent a unique parallel circuit branch between the poles of the power supply. Typically wires in control systems are marked with numbers or letters for identifications. Here you can see the function variables you can set here directly. Now what is our another one is go to modeling. Here model settings are there. In this model setting, you have to specify the following for your requirement. If you generate code, this is a code generation block. In this code generation block, here you have to you should check system target file. It shows ERT or TLC file. Okay, then this option optimize window is there. Then report window. Once after run you will get, after simulation you will get the test report and commands also. What are the things you need, you can click. Then this is a option for HDL code generation. This is HDL code generation. Target is you can fix here. Generate code for what type of Simulink file. Then you can select the language, either VHDL or Verilog, you can choose. Then also if you click means generate, you will get the HDL code. For example, we'll choose generate. Click this model. This reset false means juxtative. Select this. If there is any error means you will move to another directory. Now we can see the output. Once you simulation running it starts, click on HMI, that is a human interface. You can see the ladder for logic function block. You can see once the temperature temperature is greater than or equal to set H value, the GEQ is activates, so that the simulation run. The temperature control allows to changing the set points also there. You can able to change the set points, and also in ambient temperature allows changing the average value outside the temperature. You can see the outdoor and indoor graphs also. Either displays the heat status, and also this inside and outside temperature graphs it shows. In this model initialization, it defines the house geometry and specifies the thermal properties of house materials, and also it calculates the thermal resistance of the house. It provides a heater characteristic, that is a temperature of hot air and flow rate and remaining parameters for this model initializations. Once you stop this one, also you can see the output from logic analyzer. You can see it is especially for this temperature controller, heater, and indoor and outer temperature controller. This manner you can able to get this output. It's also the final version. You can similarly for HDL code generation, you select the option, and what is your target and device also you can select. this is a synthesis tool. It may be Xilinx Vivado or Xilinx IEC or Ultra Cortex or Microsim Libero system on chip synthesis tool. You can also select the family for hardware implementation. You can choose the family of tool. But if I want to check with this Vertex 7, also you have to choose the device type, what is the package type, and what is the speed. This also you can set. What is the target frequency also you can set. Depending upon your hardware, target hardware, you can choose. You can get the HDL code. Also optimization also available here. Optimization also available here. For example, here general format is a pipelining, is a resource sharing. These things also we can add for the adders and multipliers are utilized in your Matlab function blocks. All the things you can possible with this Matlab Simulink. Then it's a final one, our PLC code generation block. Here you can choose for especially this experiment. We mentioned the 3 target ID. Then only we will get. For example, if you are choose PLCopen XML, you will get this code generation. Don't forget to enable the click on temperature. Here also you can generate without double click on this temperature controller block. Here itself you can generate the code. For PLC code, enable treat as atomic unit to generate the code option you have to choose. And also on the design verifier, enable treat as atomic unit to analyze option you must select. Then only you will get the PLC's code or C++ code and PLC's code options. Here this one in this logic routine option. Now we can see the output. You can see now say first ring is activated. First ring activated, and then in the first ring calculates the set L and set H values. Based on this set and range inputs. Now the GEQ is activates the temp H coils if the room temperature is greater than or equal to set H. Similarly, the LEQ block activates this temp L coils if the room temperature is less than or equal to the set H value. Finally, the lowest ring turns, the heater is on. If the temperature L output is active and the heater is turned on, you can see this block heater is turned on. If the temperature L output is active, and also the heater is turned off if the temperature output is active. In this manner you can able to control by using automation process we can get. Now also one more example for this temperature controller logic. This one after run you will get this type of reusable code. This is a reusable Matlab code. Here itself you can define the house geometry and what is your things what is determine the equivalent thermal resistance for wall building, and enter the temperature here, heater temperature. Here itself you can change the value, change the parameters. You can check the analysis, check the performance of current temperature controller using this type of PLC programming. These 2 files are provided in in my YouTube channel in the description box. Kindly download it and try to PLC temperature controller simulation example. Thank you so much. Who are all not subscribing my channel, kindly subscribe my channel, like, share and comments on my videos. Please support us. Thank you.